And we're live! It's always so fun to go live. I make a big deal out of it every time. Oh, welcome to RockSim Live. This is where we're going to talk about the RockSim software and how much fun you can have with it. And we're going to answer all your questions that you might have. So now is the time. If you're watching live, you can type in your question in the comments and I will try to answer it during this episode. So we have a couple of people in the house. We have Carlos K. from Marietta, Georgia, and we have Randy T001 saying howdy. Okay, let me turn on my screen so that you can see what I'm seeing. I didn't move my monitor around. I didn't adjust everything just quite right. Okay, so if you are brand new, this is your first time watching RockSim Live, what we do here is that we answer your questions, and one of the questions that always comes up, so we always answer, is where do you find help on RockSim? If you're just starting, what would you do? For that, you would go to the Apogee website. Our website is apogeerockets.com. Let me turn off some of these things here to give it a bigger screen. apogeerockets.com, and you go to the home page, and on the home page there's this RockSim training live image. That is what we are doing right now, and if you click on that, it will take you to our archive page, which is this right here, and we are on episode number 60 today. Today is March 12th, and is it the 12th? No, it's the 11th. It's March 11th. And episode 60 is right now, and all the other episodes are archived here on the website. So if you go to this page, you can find out what we talked about in episode 59, and they'll give you the link to the YouTube video where it is so you can watch it. And then these over here, these numbers are timestamps. So if you're on YouTube, you can just scrub right over to that particular time and you can start watching, so you don't have to watch the whole thing. So you can find out exactly what you want to find. So that's what we're doing now. But if you were just starting out, I would go to the How To and Guide menu right here. Click on that, and then come down here to Software. Click on Software, and then come over here to RockSim How To Info side, and here is the video tutorials. And if you click on that, this kind of gives you a sequence to go through. You know, start with number 1. Get started by opening an existing design and run a simple simulation. Because, you know, the best thing is just run a simulation, see what's going to happen, so that when you start modifying things, you know exactly where the buttons are to start pushing. And that will walk you through, you know, your first simulation, and then what the flight profile looks like, and then flight profile preferences, you know, and then customization. And then finally down here, in video 9, was where you start designing a new rocket. And designing a rocket's not hard. But we just wanted to familiarize you with the software first before we get into designing a rocket, because then, you know, once you're into designing a rocket, then you want to see how it's going to fly and where it's going to land and all that. So that is where you would start. We have more people over here. I got my monitor that I'm watching the comments come in. And we have Rick DeFosses here, and we have David Enisman. And he writes, he's got the first question, and he says, what's the best way to finish plywood fins? I've used wood sealer a lot, but the grain on plywood is so great that sealer doesn't seem necessary. What about thin wood glue? Okay, we'll answer that. It's not technically a RockSim question, but it's a good question. If you are sealing plywood fins, plywood, the grain is so tight. What I do on plywood, I just give them a light sanding to knock off any of, there's always bumps. And so you just want to knock those off and then just go straight to primer. And the primer is you want a sandable primer when I'm talking, primer. Sandable primer so that when you sand it, you get a nice glass smooth finish and it's sealed. And then what you do is then paint on top of that. And the paint is going to act as, a moisture barrier so that, fins aren't going to warp if they get a little bit damp. If you land your rocket in, wet grass or something like that. If you land it in a lake or a river, they're going to go, whoop, like that, because they are wood. So that's the best way to finish them. I did have a question from Carlos, and he had a similar question. He says, what do you do in RockSim if you go overboard on your finishing? How does RockSim take that into account? So let's go into RockSim. And I've got RockSim Pro here. I also have RockSim. Let me open RockSim. Okay, so here's RockSim. And this gets to a very, very common question. And the common question is mass override. Because what you're doing when you add paint to a rocket is you're adding weight. And how do you account for that weight? And basically, if you overdo your finishing, it's mostly just going to be adding weight. So here is mass override. So what we're showing here is the Big Daddy rocket, which is the one that I got here in front of my face. If you can't see it. So this is what it looks like in RockSim. And if you over paint it and you put on a lot of paint to make it like glass smooth, you're going to have to account for that weight. And the simplest way to do it is using mass object, but there's also mass override, and this is where people get confused often. The difference between a mass object is kind of like a little lump of clay, and mass override is like the whole rocket. If you turn on mass override, all those little clumps of clay or masses or the fin mass and the nose cone mass, they're completely ignored, and it only uses the total mass of the rocket. So a lot of people, they'll weigh their rocket and use a mass override, which is totally fine, but then they decide, hey, I want to add more nose weight to it. Once you put in a mass override on a rocket, like this one right here, it says, this is the mass override tab right here at the top. It says this little checkbox, this is how you turn it on. It says use the value shown below for all the simulations. So it says 196 grams, and the measured center of gravity location. Center of gravity is where the rocket is going to balance. And that's it's measured from the tip. So it's 11.25 inches back from the tip. So if I go to the 2D view right here, you can see that's my center of gravity, and it's 11.25 inches from the tip. Now this rocket also has a mass override in it, or a mass object, and that's this tiny m. But right now it's using 196 grams, so you see that right there, and the CG location of 11.25 inches. So now this mass right here, if I find that mass in the parts tree, and it's probably this one right here on the nose, and let me make this screen bigger for you. Okay, so here's the mass, and if I make this mass bigger, this mass right here is not going to change. No matter how much mass I put in here, let's make it 1,000 grams, hit tab, it doesn't change at all. Now if I click OK, and I go back here to mass override, and I turn this off. Watch this number jump. Boom. Now we went all the way up to 1,265 grams, because now it does account for that mass. And then look what it does to the center of gravity. It moves it. Used to be back here 11.25 inches. Now it's way up here at the front. So I wouldn't probably not use a mass override, a global mass override, which is going to affect the entire rocket just for paint. I would probably throw it in as a mass object. So let me go back here to our parts, and let me undo this clay at the front. I don't remember what it was. Let me just delete it completely. No, I'll just make it 40 grams. And then the location, it's not going to be at the exact tip. It's going to be probably somewhere right in here, because you're shoving it into the nose cone. So I'm just going to slide it back a little bit, right about there. You can see our center of gravity is now at a more respectable location. And I'll click OK. Now if I want to account for the weight of the paint, now you can weigh your rocket. So you weigh it on a scale after you're done building it and painting it and decorating it. And so say it weighs 320 grams. So there's 20 grams of excess paint on there. So then the other thing that you need to do is to balance it. So see, when I balance it, it's a little bit further back than it shows right here. So if I add 20 grams of paint, I'm going to add another mass object to the rocket, and I want the center of gravity somewhere back here to match what's in real life. So I'll probably add the mass object to this body tube right here. It could be added to most anything, any tube or anything like that. I don't think you can add it to a fin set. So if you selected a fin, I can't add it to a fin, but I can add it to a body tube. I can add it to that body tube. I don't think I can add it to a parachute. No, I can't. Launch lug, I can't add it there. So you're looking for a component where you can add a mass object to it. I'm looking for the one that's furthest back. And so the one that's furthest back is either going to be this motor mount tube right here or this body tube right here. Since this one's a little bit further back, I'll choose that one. And now I'll add the mass object. And it always looks in the database, so I'm going to cancel out of that. I don't care what the mass object, it's just a lump of clay in my mind, although it's paint on the rocket. And we can call it paint mass. Change the name so that you know what it is. And I'm going to say it's going to be 20 grams. So we're going to add 20 grams. And right now it's going to put the 20 grams right there where that colored M is. But we want this center of gravity, we want it back here. So actually what we're going to have to do is we're going to have to move this mass object back here somewhere. And I don't know if we're going to get this center of gravity far enough back. So we'll change it by changing the location. You can see it's sliding back. It's going back, but not quite far enough. So then what I would probably do, I would click OK. Click OK. So remember this mass right here, 325 grams. So when we weigh it on the scale, that's what it says. Hypothetically, I weigh the rocket on the scale. It says 325 grams, but my center of gravity is not far enough back. So what I'm going to do is, I know I got mass here at the front. I'm going to pull some mass out of the front, and I'm going to transfer it to this one back here at the back. So let's take this clay right here, this one that's in the front at the nose cone, edit that. Let's say this is 10 grams now. Okay, look, see what happened? It moved further back. So we started at 40. We removed 30 grams. It moved further back. But now our weight here is not enough, so now we need to add it back to this mass here. So I'll find that other mass object. Here's the paint mass. Open that up, and we removed 30 grams out of the front. So I'm going to add it here. So 20 plus 30 equals 50 grams. So I'm going to add 50 grams, hit tab. And when I hit the tab key, watch what happens to the center of gravity symbol. It moves further back. That's good. So basically, that's the process. You would keep moving the mass around until your center of gravity is exactly where you want it to be after the rocket is built. Now, when you do this, always don't have a motor in it, because RockSim will account for the weight of the motor later. So you want to do it without the motor weight in there. So I'm going to click OK. So hopefully that answers the question of what do you do when you're adding a lot of paint. And so I added the paint mass right here and then adjusted the distribution of mass in the rocket so that the overall center of gravity is where it should be as I balance. And this is, this is the easiest thing to do, is to balance your rocket. You just stick it on your hand, mark it, and then measure back from the tip of the nose cone. Okay. We got another question we have from Julie Kaufman. How to set dual deployment in RockSim to my Katana rocket. Okay. Let's open up a Katana rocket. So let me see here. Applications. So the Katana rocket is in the RockSim folder. I think it's this one here. And it's in the design folder. So you find your RockSim folder, and then it's inside of the design folder. And then it's an Apogee kit, so I'm looking for Apogee. All the Apogee kits are in the Apogee components folder. Open that up, and then scroll down until you find Katana. So here's Katana, and I'll just hit open. It's going to ask me if I want to save this old design right here, and I don't really care, so I'm going to say no. And so here's the Katana. So let's get a view of this. Here's it in 3D. Let me recenter it. So to recenter it, go to this button right here, the camera controller. Click on that, and then just say recenter camera. And so it recenters the rocket right here. And then you can zoom in if you want. Use this camera controller, or you can use your mouse. Use the scroll wheel to zoom in and out, and then you can rotate it by clicking and dragging. And you could also use these buttons here. The camera controller is pretty nice. But it has the buttons to recenter and reset. Reset, what it does is when you click on it, it takes the rocket, whatever orientation it was in, and it just turns it back to horizontal, nice and flat. And then I'll just zoom in again, and I can rotate it around. It doesn't really matter. Okay, so that's what it looks like. And if we look at it in 2D, what I want to verify that it has two parachutes, because with dual deployment, that's the purpose of it, is to deploy two parachutes at different times in the flight to minimize the amount of walking distance that we have to do. Okay, so here's one parachute, this orange one right here, and then here's another one back here. Let me zoom in. So the P stands for parachute. And there's also a mass object, which we were just talking about, right next to this one. Let's see if I can't select it. It's probably this mass object right here, which says 15-foot long shot cord. And there's another one here in the front, and that's another mass object is a 10-foot long shot cord. Okay, so we have a big parachute in the front. It says 48-inch. And then the one in the back is, it doesn't tell me how big it is. So let me open it up. It says 18-inch. So I'm going to change this to 18-inch parachute and click OK. Okay, so now we have an 18-inch in the back, big one in the front. So in dual deployment, what we do is we throw out the small parachute first and when the rocket is really high, and then because it has a small parachute, it's going to fall like a rock. And that's what we want. We want it to fall fast so that any wind that's blowing across the field doesn't take it and drift it. If we would deploy the big one at the top, it's going to fall slow, and then the wind is going to make it drift. And that's the exact opposite of dual deployment. Because it's going to drift really far, and we don't want that. We want it to come down as close to the pad as possible. So this is the parachute that we want to deploy first. This is the one that we're going to deploy second. Okay, to set that up, we're going to go and run a simulation. So this is the simulation button right here. This is preparing for launch. And so it looks like the base of a rocket with two arrows pointing down to a disc. And that disc is our blast deflector. So that's what that symbol means. So that's prepare for launch. We're putting the rocket on the rail. Okay, so we're going to do that. First we have to select, we're going to move across these columns right here, these tabs. First one is engine selection, so we'll choose an engine. And I want something big because I want it to go high. So we'll pick this Aerotech K535. And then we have to select the delay. The longest delay is 14 seconds. So now in dual deployment, what's going to happen is it's going to have an altimeter in the rocket. So the altimeter controls when the parachutes are released. So the drogue parachute, we want it to be released right at Apogee, because that's the highest point in the flight, and it's also the slowest point in the flight after it leaves the launch rod. It has no vertical velocity, and so when it hits that apogee, it stops and it starts coming down. It could be going sideways, but as long as it hits that top of the curve, that is still going to be the slowest point. So that's where we want it to deploy, at apogee. And then the big parachute, we want it to deploy closer to the ground, anywhere from 200 feet to 800 feet. If you're doing this for the first time, you probably want to set it higher because you need to learn how long it takes for your parachute to open. Because some parachutes, the way you pack them is going to determine how fast they open. And so you're gauging your own skills in packing a parachute. And so for your first launch, you better be conservative. So assume that it's going to take a long time to unfurl and then completely blossom open. And during that time, it's going to fall pretty far. So if you deploy it too low, it might be on the ground before it finally opens. And then that kind of defeats the purpose of dual deployment too, because now you're going to break fins off your rocket. Okay, so right now, I don't know where my apogee is. So I want to choose the longest delay possible. And then from the list, the longest one is 14, although I can set it longer using custom. And then typically, the altimeter is going to fire it off. The altimeter senses when apogee occurs. So click OK there. And then, so now we're going across this tab. So the next one is, so we loaded the motor, the K535-14. The next event is the flight events tab. And so here's where we're going to set up our parachutes. So I'm opening this up here to see which of these devices, and this is why I changed the name so that I could tell them apart. Because if they both say parachute, it's really hard to figure out which one is which. Now that I have them labeled, I can say, okay, this big one is the one that I want it to deploy low towards the ground. This upper one, I want to deploy at apogee. So then under the event description, so this one I want at apogee, so I'm going to click on this selector here, and you can see I have a number of choices, and I want to choose deploy at apogee. So this will always pop out at apogee, regardless of what the delay is. So basically, by doing this, we've just ignored the delay. Although right now we still have delay selected for the top one. So this one is also going to be deployed by the altimeter. So now this is where we're going to deploy it at a specific altitude. And like I said, anywhere between 200 to 800 feet. I've seen people set them at 1,000 feet, which is fine. It's going to be a little bit more of a walk because the higher up you are when you open that bigger parachute, it's just going to take longer to drift down to the ground. But it's conservative, which means that depending on how you pack it, it's you know, I'd rather it deploy too high than too low. Because if it deploys too low, that means you're on the ground. So let's say we're going to deploy this at 600 feet. So you come over here, so you select deploy at altitude, and then you have to type in a number. So this number, I'm going to type in 600 feet, and then you have to hit the tab key. So you hit the tab key for it to accept the number. Okay, so now we have it set up. So now we're going to set up the rest of our launch conditions. Starting state, ooh, I only got a 1-inch launch rod. Let's make that 98 inches, which is 8 feet. And our launch angle, let's go, 2 degrees. I'm just grabbing this and, it came up to 2 degrees, 1.999. Launch conditions, here we have, we're launching at an altitude of 700 feet. And we have a constant wind of 8 miles an hour. So that to get a constant wind speed, you select custom speed range, and then you type in the same number for the low wind speed and the high wind speed. So that means it doesn't vary. All right, and then we're going to ignore competition settings. Okay, so now we're going to do flight profile and click launch. So it ran the simulation and it brings up the 2D flight profile. So this is where the rocket is sitting down here. And here's the launch button. So we're going to click launch. And the rocket's taking off. And you can see the altitude right here. We're at 4,000 feet. Close 5,000 feet. Still going up. 6,000 feet. 65. Still going up. Okay, so now we're coming down. So it was about 6,800 feet, and it's coming down. You can see it's drifting down slow. But is that too slow or is that too fast? It's hard to say at this point. Then I want to speed things up here because this is going to take a long time. I got all this time here left to go. And the main parachute's not going to pop out until 600 feet. So I'll just grab the slider and just move it down to right above 600 feet. Okay, we're at 737 feet. So we're getting closer to the ground. And now the main parachute popped out. It's hard to see the difference here. But you can see by the dog leg, see it was coming down fast, and then the trajectory changed. It went from this slope to a flatter slope. That means it was coming down slower here. And it landed about 395 feet away from the pad. So that's fine. That's cool. So that's how you set up dual deployment. If you want to get a better view of this dual deployment, let's open this same design up in the launch visualizer. So I'm not sure if I have a katana in the launch visualizer. Actually, I do. So we had, what was that motor? It was a K535? Okay, K535. So let me open up the launch visualizer. The launch visualizer is at the website RockSim.com, and you can go there right now. So if you open up like an incognito tab on your computer or just another window, you can go to the RockSim.com website. And I don't think there's a sample design of the katana in there, but hold on, there is a katana, but it may not be in there right now. So under demo designs, I'm scrolling down. No, there's no katanas under the demo designs. Under my user design, it's not letting me click here, which means I'm not signed in. So let me cancel out of there and sign in. So I'll go to here to log in. And here's my account. I'm signing in. Okay, I am now signed in. And you can tell when you're signed in if you click on the profile button here. You know, you can see I'm logged in. I got this email popping up and showing up these alerts. Okay, so I am logged in. Now I'll go, if I go to choose design, I can go to users designs, and let me scroll through this list. Let me just, or I can just search katana. Katana, nope, there's no katana. Still okay, don't worry. Let me open up a new tab here. Let me go to the Apogee site, apogeerockets.com. And here on the Apogee site, we'll search for katana. Here's the katana. That's what it looks like in real life. It's a beautiful rocket. That's what it looks like. That's how big it is. I didn't tuck in my shirt that day. Okay. What you're looking for on this page is I'm looking for the launch visualizer widget. And where's my widget? There it is, right there. It says "See It Fly." Free realistic launch visualization. Click here. So when you click on this, it launches the launch visualizer, and it will also bring up the katana rocket in the launch visualizer. So here's the katana, and you'll see it sitting here on the pad. It's still loading. Okay, so now, but this screen that we're seeing here is kind of small. We want a big screen. So what you do is you scroll back up to the top, and then you just click on the launch visualizer button up here. And it brings up the whole launch visualizer and the katana in a brand new tab on your computer. And it's going to load it here. And if you'll notice, since I logged in previously, I am not logged in. It logged me out. Signed me in again. It should have seen me that I was logged in. Okay, so it's probably going to go back to the Avion. Okay, nope. It gave me the katana. That's good. Okay, so I'm going to close that launch visualizer window there because I don't want to have two of them open at the same time. So here's the katana. So now, the cool thing about the launch visualizer is I can launch it in a real launch site. So first I have to select a launch site, and this is where, I don't know where you are, Julie. I'll make up a launch site for you. So I'm going to choose launch site, and I'm just going to grab one from the list here. I'll probably grab a Tripoli launch site, Tripoli, Utah, and click OK. And over here, it's going to load a map, an image of the launch site, and it looks kind of brown. This is Utah. And I'm zooming out so I can kind of see a perspective of where I'm launching from. I'm going to click on the 2D, and it's going to switch me to looking straight down on the launch site with north straight up. Okay, so I'm looking for landmarks here. Okay, so here's Provo, Utah. Salt Lake City's up here. Up here is the Great Salt Lake. So that's kind of where that launch site is. Let me zoom back in. I can launch in any direction on this launch site because there's nothing around. There's no obstacles here. So let's launch it kind of to the northwest. So keep that in your mind. And I'm going to go to the starting state, and I'm going to adjust the launch angle. Before we were almost straight up. So I'll just say 4 degrees, but I want it to be kind of to the northwest. And if you saw right here, again, you can zoom in with your mouse to see what the angle looks like. See, if I rotate it around, it's rotating it around the compass. But I said I wanted to go to the northwest, so I'm going to go right there. All right. Before we had an 8-mile-an-hour wind, so let me set up an 8-mile-an-hour wind here. So I'm just going to type in 8 miles an hour. Come on. 8 miles an hour. And I click OK, and it's coming out of the west. So here's west here on my compass rose. So the wind, you can see this angle, see this arrow right here, that's the wind. It's coming straight out of the west, blowing towards the east. Now we need to select our rocket motor. So you go to this tab, then choose engine. This is just like RockSim. And then we're looking for that K535. Okay, so I typed it in the search bar just to find it faster. There it is. Click OK, or I can select my delay. Remember, we selected a delay of 14 seconds. Click OK. So now it's loaded in engine. Now we're going to set up our flight events. So I'm going to go to the Flight Events tab. And okay, so on this file, I didn't change the names, but I know that this one's the 48 inch, so this must be the 18 inch. So the 18 inch parachute we want to deploy at Apogee. And then the 48 inch parachute we want to deploy at an altitude. And then you have to type in an altitude here, and we said it was 600 feet. Make sure, oh, it says meters, so I'm in meters. So if I don't want to be in meters, I got to go to this tab right here called My Data, and then go up here to units. And I should have been in feet, because I'm showing my altitude in feet. Let me go back to here, see if that's okay. So now it did change it to feet. It converted it, so we'll go back to 600 feet. Hit tab, and now we're ready to launch. So you saw that the view changed, which is okay. Down here is the launch button, so we'll click launch. You don't have enough credits. What do you mean? Let me see in my profile. It says I have 0 credits. How did I use up all my credits? I need more credits. So if this happens to you, what you do is you buy booster credits. There's regular credits and then booster credits. So I have no idea why I got reverted to without credits. This is embarrassing. So I'm going to top off my credits here over here on my monitor screen. I'm waiting for it to load. While it's doing that, let's see if there's any other questions. Carlos says, he's talking again about paint mass. Is there a case for the paint mass at the center of pressure? No, Carlos. Just put the paint mass. In the paint mass, what it's going to, the only thing it affects is the mass of the rocket. Center of pressure only is affected by the aerodynamic forces on the rocket. So the paint doesn't affect the aerodynamic forces at all. So it only affects the mass. So you don't have to worry about where the center of pressure is. Just put the paint mass so that your final center of gravity is at the right spot, is where you balance it. Okay, I have to. Why, oh boy. Current credits. Let me put in some credits. Okay, so I've put in new credits. The problem is I'm going to lose my katana. So that's the Apogee website. So I gotta, in order to get my credits, I have to log out and then log back in. So if I just refresh, I don't think it's going to change anything. It has to, oh. Yeah, see, still 0 credits. So I'm going to log out and then log back in, and now I'll have credits, but it probably has to load the rocket first. Okay, so now I got 40,000 credits. Okay, now I can do this launch. Deploy at maximum. Okay, so it reset things, which is what I figured it would do. So I got to choose my engine again. Okay, 535. Click OK. Flight events. I'm going to deploy this one at Apogee. Deploy this one at altitude. And it went back to meters. Why did it do that? It should remember my units. Click OK. And go back here to this, and I bet you it. Okay, now I'm in feet, which is what I wanted to be. 600 feet. We've got the rocket motor loaded, but now our launch site got messed up. And our wind was at 8 miles an hour. It's at 8 kilometers per hour. We want miles per hour. Click OK. And our launch site, that was that Utah site from Utah Tripoli. So I'm typing in Utah, and we'll pick that one. And it will reload the map, and we'll just confirm it was the same place or someplace pretty close. Yeah, that's the same one. Okay, so now we're ready to launch. So now I'm going to launch, and I have the credits. Simulate. It's strange that I lost all my credits. I'm going to have to ask my programmers. Maybe they're playing a joke on me and turned all my credits off. Totally possible. Okay, so David Ansman has a question about mass override again. Let me finish this one right here. So what's going on here is the rocket, the elevation is not matching the exact map. So if you want to see the bottom of the rocket, you come up here to the settings. And one of the things that I can't do is I can't see the rocket except for this little image right here on the side. But if you scroll down here under the flight screen preferences, there's a ground elevation adjuster, and you can see, I can see that I moved it up. So basically I moved the ground down or the image of the ground. That's really all that it affects. Then click OK. Okay, so now we got the rocket sitting on the pad. I want to look at it from a trajectory view. So if the rocket is way small down there, but it's going to go way high. It's going to go pretty bloody high. So I'm going to launch it. You can see the rocket's taking off. You can see an enlarged view here, but the trajectory view here. Oh, and we're going to go out of the screen, so we have to zoom out to see the rocket where it is in the sky. Okay, so there it is. I zoomed too far out. Clicked the button too many times. Okay, so now what we're looking for is that parachute deployment. So one parachute is out right now, so I'm going to pause it. And you can see the rocket is now vertical. So that means our parachute is out. If you want to find the rocket, you click this button right here, you just find the rocket, and what it's going to do is going to put the rocket right in the middle of the screen. So it's dead center in the middle, and now I can zoom in. And what we should see if we keep zooming in is the rocket hanging below a small parachute, and that looks to be about an 18-inch diameter parachute. So let me zoom back out, and when the big parachute comes out, that should change. So right now we're at an altitude of 5,956 feet. And I'm going to take the slider bar and I'm going to slide it until it gets to right below 600 feet. So we're still over at 2,000 feet, 1,500, 900, 700, okay, it's 569. So now we're below 600 feet. So I'm going to find the rocket again. You can see it's way lower, it's right here. I'm going to zoom in. And you can see that this parachute is much larger than the last one. It's the same color, but it's larger. And you can see the as the rocket's coming down. Let me zoom out a little bit. I lost it. Let me zoom out a little bit more so you can see that what I'm going to talk about here. So this green line is the trajectory of the rocket coming down. Once the big parachute comes out, the trajectory changes. We're going to see that dog leg like we normally see when we have dual deployment. So you can see it. See, it was coming down this trajectory, and then right here at this point it starts coming down slower, which is exactly what we want. And I can zoom out and I can see the entire trajectory. These vertical lines here are 1 second apart. Because the rocket is coming down so slow, the lines get closer and closer together, and that's why it turns into a solid color. But you can definitely see, you know, it was coming down, and then right there, it changed descent rate, and it was coming down nice and slow. And so now we're at a distance of 1,700 feet from the pad, and for all practical purposes, it's on the ground. So if you didn't have dual deployment, so let's run that same simulation and deploy that big parachute at Apogee. So the small parachute, let's say never deploy or no event, and the big parachute, let's deploy it at Apogee, and then just see what the trajectory looks like different. So I'm going to launch it. Take a drink of water while I'm doing that. Okay, find the rocket. There's the rocket. Again, it's underground, but that's okay. Okay, let's launch it. Rocket's taking off. Let me switch to a different view here just so that we can find the rocket pretty fast. It's going up. You can see all these little dots are probably groundhog holes. It's going over the top. Right when it gets horizontal, that's when the parachute came out, the small parachute. So if I zoom out just a little bit, I should see, oh, no, yeah, the big parachute. Okay, so this rocket takes, I think the last time was about 121 seconds in the air. Now it's 248. So we can tell this is coming down a lot longer. So I'll just take it and drag it all the way to the end. Holy cow, look at that. 1,500 feet away from the launch pad. So that's before I think it was 1,700 feet. So, okay, so here's the launch point right there. I think before we probably landed somewhere over here, 1,700 feet away. This time the wind, it did carry it further away from us. If we look at it from the top, we can get a better perspective. Okay, so here was the launch point. It's now landing here. I think the last time it was probably landing somewhere over here. This path right here as the rocket was going upwards, that stays the same. It's only with the parachute deployment that changes different. So this going up, so this part of the green line going up is the same as the last launch, but it's the coming down part that has changed. So because we launched at an angle, and the rocket weathercocked into the wind. Dual deployment didn't save us a lot. In fact, we have a further walk because the rocket, because it weathercocked so far into the wind. That's why dual deployment didn't save us. So you would never know that unless you had the launch visualizer on your Katana rocket. So yeah, I learned something new myself. I like that simulation. So I'm going to save it. So I'm going to do share that simulation. And so here's the link. And I'm going to take that link and I'm going to put it into the comments here on YouTube. It launched my email program right there. So I want to copy that link. Don't save that. And I'm going to put it in the comments here. So everybody can now click on that and you'll see the exact thing that we just saw here. Okay, so let's close out of the launch visualizer and go back to David's question. He has, in your example, the mass of the rocket without the added nose weight clay is different from the value of the mass with the mass override on for the sustainer. Which do you start with? Which is accurate? Okay, so let me do file, open recent, Big Daddy. I don't care about saving that one, so click, okay. So 196 grams. So which is most accurate? The most accurate is the exact weight of the rocket as you built it. So we talked about this last week, is how do you know your RockSim file is correct? And you have to actually compare it to what's in real life. So until you actually build it, everything is hypothetical. So like in that Katana rocket that we just did, everything was hypothetical until we actually compare it to what's in real life. And then from that point, then you have to adjust your RockSim file to match real life. Like, I don't have a scale right now to actually weigh this Big Daddy rocket. So let me go to the Apogee website and I'm going to type in Big Daddy because we sell this kit. Okay, so here's the Big Daddy. And so say in real life, I weigh the rocket and in real life, it matches this. And this is probably pretty close because at Apogee, we actually build the rockets before we put them on our website. So I'm pretty confident that 150 grams is what this one actually weighs. So now I need to match this rocket here in RockSim to real life. So this is what people most will do is they'll say, okay, it's 150 grams and let's balance it. So I'm going to balance it here and it looks like the center of gravity, and I'm looking at where my launch lug is, and it looks to be about maybe an inch and a half in front of the launch lug. So on my screen right here, I need my center of gravity to be about right here. So right now we're using 11.25. Let's make it 13 inches. Okay, so that's too far. Let's go 12 inches. That's a lot closer. Maybe it's going to be like 11.75. But in real life, I would actually get a ruler out and measure it from the tip of the nose cone. And that would give me my most accurate location for that center of gravity. Now, at this point, let me quit that again. I can't add any nose weight because I've got a mass override. If you don't want to use the mass override, then you need to adjust all the components in your rocket or add mass to the rocket. Okay, so right now, here's method number one, is to use this mass override right here. But if you want to add more nose weight in the future, you probably might not want to do that, because whatever nose weight you add, this value right here is always going to take precedent. It's always going to be a global setting, and it says, okay, this is the final mass of the rocket right before I launch without the rocket engine. So if I uncheck it, RockSim thinks that this rocket weighs 275 grams. So I now need to lose about 75, about 100 grams. No, take me down to 175, 125 grams I need to pull out of this rocket. And at the same time, I need that center of gravity to be about, what did we say it was? 11.75 inches. So how do you do that? Okay, so first, my mass center of gravity is not far enough back. But everything is too heavy. So I'm going to start going through the components and starting to, all the ones in front of the center of gravity, I want to make them lighter. So my nose cone. So currently, if I edit my nose cone, let me make sure it says mass override is on. So to turn that off for the nose cone is right here. It says using it as 150 grams. So I say, no way. So if I uncheck it, now it thinks the calculated mass of that nose cone is still 163 grams, which is too heavy, so I need to make it lighter. So I can make it lighter two ways. Either one, change the material. Actually, there's a number of ways. I can make the wall thickness thinner. So if I change the wall thickness from 0.125, so that's 1/8 inch thick plastic. And there's no way that's 1/8 inch thick plastic on that nose cone. So let me change it to like 0.06. So now the mass of that nose cone dropped to 81 grams, and our total mass on the rocket is 204. Still not light enough. So let's make it a little bit lighter, like that. 191 grams. This is getting better. And the center of gravity is moving further back because the nose is getting lighter. And so right now our center of gravity is 11.23 inches from the nose cone, and we said 11.75. So we need to move it another 1/2 inch back. So I'm going to go to this mass object right here. What did we say it was? 10 grams. Okay, let's pull that right out and delete that nose mass. Really delete it? Yes. Bam. Okay, so now we move the center of gravity back. Now it's too far back, but we're still not light enough. So now that it's moved too far back, now we need to pull weight out of the back end. So we'll find things in the back end. Maybe a fin. You know, I don't know, what do our fins weigh? Right now they say as a set they weigh 10.29 grams. That's probably pretty accurate. So I'm going to leave my fins alone. What else can we adjust? Centering rings. This centering ring right here has a mass of 5 grams or 4.5 grams. We can make it lighter. We need to get another 30 grams out of this rocket. Man, we need to lose a lot of weight. So I can, to make that centering ring less, I can change it from the mass object, and I can say, let's make it 3 grams. You know, every little bit helps, and the center of gravity on that centering ring is from the front of the centering ring. So our centering ring is 0.1 inches thick, So our center of gravity should be 0.05 inches from the front of the ring. So that's this. You can see how tedious this is getting. Let's go to the body tube here. This is the motor mount tube. We could probably, this one only weighs 4 grams too. Where is all the weight coming from? It's probably the parachute. So on this one here, let's do a mass override on this. And let's say that this weighs 3 grams. I'm getting lower, and my center of gravity is now moving forward again. Now it's moved too far forward. But you get the point, is you got to adjust every component. This is why, as you're designing a rocket, you want to put them in at the correct weight at the very beginning so you don't have to come back to it later. So how long was this tube? This tube was 5 inches long, so that means our center of gravity is going to be half of 5 inches, is 2.5 inches. And I click OK. Let's go to the parachute, see what our parachute weighs. Calculated mass. Okay, this one has a mass override on. So let's go to the mass override, and it says it weighs 3 grams, which is pretty light. I'm going to leave that alone. That's like pretty good already. Let's check this big body tube, see how much this one weighs. Okay, so this one has a lot of weight. This one has 85 grams for the big body tube. I don't think that's correct. So we can make that one lighter. So what was the length? The length is 10 inches. So we need to pull out approximately 25 grams. And it says 85 grams, so 65. Let's make the mass 65 grams. And the CG is going to be at 5 inches. Okay, so now we're down to 158. So we need another 8 grams. So 15 minus 8 is 57. So now we're down to 150 grams. But our CG is, now it's a little bit too far forward. So we need to move the CG back. So I can probably move that CG back by adjusting this CG position here. So this tube, instead of balancing in the middle, let's say it balances a little bit, we're going to fudge, we're going to move it a little bit further back. Let's make it 6 inches back. By making it 6 inches back instead of 5 inches from the front of the tube, we're at 11.72, so now we're 0.03 inches. So let's just tweak this just a little bit more. That's too far. 7.6, no. See what I'm doing there? I'm just kind of moving that CG around until this number here is 11.75. And click OK. Okay, so at this point, the rocket is as built in real life. So we've matched real life. So the rocket weighs 150 grams, and it balances at the correct location. It took a lot of work to get there. It would have been better to do that work up front as we're putting it into the program, but you can come back later. It's just more work. So then we can run our simulations, and now they should be pretty good. So hopefully, David, that answers your question. We have Tim Godin from Sunbury, Ontario, waiting for winter's retreat, but maybe breaks this weekend. Cool. Yeah, we have cold weather here in Colorado too. Let me go up here. Right now it shows Colorado at 30 degrees Fahrenheit, so we're below freezing right now. Tomorrow we're going to get up to 54 degrees Fahrenheit. So yeah, we're waiting for it here in Colorado too. Clint Brownings says hi from North Carolina. I use elastic cords in my mid-power rockets. Everybody tells me that's no good. Why? It's not that it's no good. Clint. It's just that you have to be careful with anything that has rubber in it, because rubber degrades over time. And so over time that elastic is going to get brittle, and eventually it's just going to fail. You're just going to pull it, and it's going to be like old rubber getting cracks in it. It's just going to fail. Typically we like to use Kevlar, because Kevlar doesn't degrade over time. The Estes ones use rubber, which is totally fine. What you should do, and this goes for everybody, this is a pre-flight inspection of all your rockets, is right before when you're prepping your rocket, pull on it, pull on the shock cord, pull hard, stretch it out, pull on both ends, pull on the bottom, pull on the top. Make sure that the rubber is not going to break on that flight. So that's common pre-flight checklist, is to test your shock cords. If the downside of Kevlar is that it has a tendency, if you choose the wrong delay, you can rip the side of your tube. It's called a zipper. Typically it happens when the rocket is coming downwards. If your rocket is pointing down, what happens is the nose cone comes off and it comes up to the side, and it's just taking that shock cord and it's running it right up the side, and if it's going fast enough, it's going to zipper it. So a lot of people will do a hybrid system of elastic and Kevlar in the shock cord. And if you look at the North Coast rocket kits, that's what they do in their kits. They have a really long Kevlar and a short elastic. So as it comes out, and they're in parallel, so they're two lines that run parallel to each other. And as they come out, the elastic is stretching and slowing the nose cone down. But if it gets too far and the elastic breaks, then the Kevlar will still keep everything together. And so you get the best of both worlds. You get the slowing effect of elastic with the strength and durability of Kevlar. That works really good. And the way they do it is in parallel. There are some manufacturers that will put them in series. So the bottom part is Kevlar and the top part is elastic. And then basically you still have the problem of the elastic over time is going to get brittle. So you still have to tug on it. So I like the North Coast system, if you want to go with that route. So hopefully that answers that question. Rick DeFossa says, planning to visit Apogee Monday, if all goes well. Cool. Let's see what the weather is like on Monday. Monday, 48 degrees and partly cloudy. Okay. Yeah, you're welcome to come. And we have Fishing and Fireworks says, can I run on iPad? The answer to that question is, which software are you talking about? If you're talking about RockSim, no. But if you're talking about the Launch Visualizer, yes. So remember, the Launch Visualizer just runs on any browser, so your iPad does have a browser on it. So, just rocksim.com is the Launch Visualizer, and that you can run on your iPad, you can run on your phone, you can run on a Chromebook, because it runs in the cloud, and that's the future. I'm trying to put everything into the cloud so that whatever you're running on, it will work. Okay, Clint Browning. I forget what Clint Browning's question was. He says, "I'll do that. Thanks, Tim." And okay. So Fishing and Fireworks is, he confirmed he does want to run RockSim on a iPad, but unfortunately it doesn't run on an iPad. But RockSim Launch Visualizer will. So for the launch visualizer, you just need a RockSim file. And I showed you on the Apogee website, we have all of our files for all the Apogee and the Dynastar rockets are already there. Other manufacturers, you can download them from the internet. You know, say we didn't have the Exodus Big Daddy. I'm sure it's on the internet somewhere. To find it, what I always, oops, why would I click on that one? Quit reminders. What you would do is you would go do a search and just say, you know, the name of the rocket kit plus RockSim file. So I would say Estes Big Daddy RockSim file. So do a search on that, and it shows you'd start clicking on these links. So I can see this image right here. Looks like a RockSim file. Big Daddy RockSim design file, and that's on rocketreviews.com. And so there's thousands of RockSim files out there that you can download, and then in the launch visualizer you can upload them into the launch visualizer, so you can run all your simulations there. The one downside is that you can't modify the files. So like before, what we were doing is we were modifying the center of gravity location. You can only do that in RockSim or RockSim Pro. You can't do that in the launch visualizer. Someday in the future, that's our goal, but we're not there yet. Okay, so we have gone over an hour already, and I think that's all the questions that I saw. So I think we can be done. So thank you for coming again this week. I had a good time. You had some really good questions. I hope you learned something. I learned something when I was doing that Katana flight. Sometimes dual deployment doesn't save you a walk. It depends on the trajectory of the rocket going up as well as the trajectory coming down. So I have to file that one away in my internal memory as something that I learned today too. That launch visualizer is just awesome, you know, because I would have never have figured that out probably had I not seen the trajectory in real life like we saw in the launch visualizer. Okay, so thank you for coming, and we will be back next week, same time, which is 2 p.m. Mountain Time, which is 4 p.m. on the East Coast on Friday. And that will be episode number 61. So in 5, 4, 3, 2, 1, go out and launch something.